Welcome. I'd like to ask you a question. Can you afford to be offline? If your answer is no, stay tuned and let's discuss adding redundancy to your Internet gateway. That's where multi-WAN routers come in. Devices with smart failover and load balancing capabilities, each with its unique design perspective, its own ecosystem, and a distinct target audience in mind. In this episode, we'll look at the Spitz Plus by GL.iNet, a device built with ease of use and portability in mind, providing multiple connection options, an intuitive app, a web interface, and even a peek under the hood for those who are interested. So, if downtime isn't an option, this series might be for you. Let's get started. This is a review of the Spitz Plus router by GL.iNet. GL.iNet is famous for its travel routers. However, the Spitz Plus is a separate device class, a 4G LTE-12 router providing Wi-Fi 6 and gigabit Ethernet connectivity to your network. Such a device will find good use whether you're traveling, on holiday, working remotely, or simply need a backup connection to your main line. During the quick unboxing, I've taken note of the multiple mounting options included in the packaging for this compact router. Adhesive and screwing mounting is provided using a slide-on quick-release base, targeting both RVs and easy home installations. Finally, using one of the 3 plugs included for the power adapter, we can turn the device on. Open the setup leaflet, scan the QR code, and then download the app from the App Store or Google Play. Once the app is installed, we can proceed with the setup. To set up the Spitz Plus, we first have to connect to it through Wi-Fi using the settings that are on the side of the router. After that, we are connected and we see the main screen where we appear to be online. The 2 Wi-Fi networks 2.4 and 5 GHz are up, and the connected clients, my phone in this case, appear on the main screen. We need to proceed and secure the device. So let's go to System and first check that we're on the latest firmware. Let's also set up the time zone, which is important both for our logs and for some of the later settings. Now go to Security. If you haven't changed your admin password on the initial setup, change it now. Enable SSH login, change the port, and enforce HTTPS for the web interface. On the remote access control, disable everything. Now that we've set up our device, let's get connected. In the Internet menu, we can proceed to the networking wizard. Set up an Ethernet connection on one of the 2 gigabit ports. Set up a cellular connection using any of the 2 SIM card slots, though this is a single modem device, so only one 4G connection is up at any one point. You can also connect to an existing Wi-Fi network in repeater mode or use a USB cable to tether your mobile phone. Let's have a look. Let's log into the web interface, and with any SIM card inserted before the device boots up, we can proceed with configuring. If no PIN is required, auto setup will just work and you'll get connected. If any cellular connection is configured, the signal bars will light on the device, and more information on the connection properties will be available through the web interface, including signal strength, and you can even view the cells to which you're connected. If you need more control over your setup, you can set up manually and then insert PIN, specific APN, and even authentication settings if you require them. If you're handling multiple SIM card configurations, you can save and restore them through Manage Profiles. Moreover, you can look at graphs for your signal over time. Finally, I'll connect through Ethernet and run a speed test on the 4G connection. In repeater mode, we become a client to an existing Wi-Fi network. We simply click Connect on repeater, choose the Wi-Fi network, enter our credentials. Now any device connected to the Spitz Plus will be able to use that connection with the added benefit of being behind a firewall. For example, a LAN client here is connected to the Spitz Plus, which is then connected wirelessly to the rest of the network in repeater mode. If you wish to tether your mobile phone, make sure that USB tethering is switched on in mobile phone options, and then just connect it through USB cable to the side of the device. Choose Tethering and connect. Spitz Plus will then be able to use your mobile phone's network via USB cable to connect to the internet. Once we have more than one connection set up, we can proceed with our multi-WAN configuration. In failover mode, we first define our interface priority, whereas in load balance mode, we define the load ratio between active devices. Now the Spitz Plus will keep tracking the status of our links. In failover mode, the highest priority interface will be providing connection. If that connection drops, the next available interface will automatically take over. Whereas in load balancing mode, new connections are on average split between interfaces according to the predefined ratio. For example, I'm connected to my mobile phone network hotspot in repeater mode here, and I've also set up a secondary cellular connection on my Spitz Plus. Device is set up in failover mode, with repeater being higher priority than cellular. This priority is easy to change. Let's, for example, change cellular to be higher priority than repeater and see what happens. Back to the internet. Now you see cellular is above repeater. And finally, we can switch it up to the way it was before. It's that easy. And here we go. The Spitz Plus also offers ways to encrypt our connection to the internet, creating a virtual private network. WireGuard and OpenVPN are supported both in client and server modes. Moreover, GL.iNet is kind enough to provide theoretical throughput maximums in client mode for WireGuard and OpenVPN in ideal conditions. Other VPN protocols are supported through plugins, and you can also run Tailscale on this device if you need to. There are a number of additional features that are exposed to the user through the web interface. You can add functionality to your device via more than 600 pages of plugins. Even configure a simple file server, complete with user and share management by connecting your drive to the USB 2 port. You can enable AdGuard to prevent set up parental controls, and you can even separately purchase from Simpoyo a SIM card that enables eSIM management on your device. Finally, there's a plethora of network configuration options, including port forwarding to the DMZ and setting up separate DNS servers. Under the friendly interface presented by GL.iNet lies a heavily customized version of OpenWRT, a Linux-based operating system for embedded devices. We can therefore SSH into the system, use and update OPKG to install LuCI, the web interface for OpenWRT. This is a limited shell, and it's a fully writable file system, so we should be very careful. However, we can take this opportunity to verify the options we selected using the web UI. We can check open ports, both in TCP and UDP using netstat, and also use IPtables to check firewall rules and default policy, and verify that what we've set up is working correctly. There is a lot of power that comes with access to the shell, obviously, so this is the reason why we don't expose it to the web. Now let's proceed and see the web interface, LuCI. Now we take a look at LuCI, the web interface for OpenWRT that we installed earlier. First of all, we note that the current firmware is running on OpenWRT 1907 snapshot. Moreover, we can have a look at the firewall rules to verify the security of the device, something that we cannot do on the default web interface provided by GL.iNet, as I suppose it's not conducive to ease of use. It's fair to say here, however, that we do get the ability to install LuCI separately, and that not everything exposed by LuCI works well on the device, so running it by LuCI alone would not be feasible or effective. GL.iNet has carved out a very specific niche for itself, and the Spitz Plus is a clear reflection of that, with OpenWRT at the core, a layered UI, and a simplified dashboard up front. It's both approachable for casual users and has depth for the power user. There are many other devices up and down the price range in terms of hardware by GL.iNet, but in our opinion the Spitz Plus hits the sweet spot of price to performance at around €200 at time of filming. What's relevant for our series specifically, though, is that this device is designed with failover in mind. There are trade-offs, however. Build quality is functional rather than industrial, although the size of the device and the history of GL.iNet suggests that this device is designed to accommodate travel. The device can get pretty hot under constant use. This is addressed by a fan, which, although inaudible, can add another point of failure. The ecosystem with a polished interface by GL.iNet, but with packages coming from OpenWRT, can feel a bit inconsistent. Finally, the version of OpenWRT running on this device is not the latest, and there are vulnerabilities that can only be addressed by firmware updates from the manufacturer. In closing, this is a device for the prosumer or enthusiast buyer, building redundancy into their Internet Gateway setup. This is a very compelling proposition at the price point, and whether it's right for you depends on your specific need. This has been the GL.iNet Spitz Plus. Thank you for watching, and I look forward to catching you later in the series. Bye bye.